So what is GitOps, right? GitOps is essentially a, think of it as a concept, think of it as beyond infrastructure as code, but think of it as operations via pull request. I mean, the people who started this movement, or well, the people who brought out software that, is pushing this movement were the guys over at Weaveworks. And they came out with a lovely package called Flux, which kind of revolutionized the way we think about, CI and CD. Now, there are two high-level concepts, which we are probably used to. Well, we're used to the former, which is CI ops. And CI ops is what everyone knows today as build your containers, for those of us who use containers, or even if we don't use containers, we're using regular, application deployment pipelines. You build your application, you deploy the artifact, and then your CI environment orchestrates and does the actual deployment. Now, one of the drawbacks to this is that you have to share credentials with your CI, environment, and your CI environment is the one who then takes your application code, connects to your cluster, or connects to your production or staging or development environment to actually do the deployment. Now, in a lot of cases, we've seen where CI environments don't belong to you, right? You've outsourced it to like the Circle CIs, to the Google Cloud builds, to Travis. There are quite a number of them, that are very popular. I mean, it probably makes more sense to just offload all, continuous integration tasks to one of these cloud providers than managing and running your own, which, to be honest, you can do. I mean, of course, the level of effort much higher there because you have to manage those systems, get them up to date, make sure dependencies are up to, everything is up to date. Now, even if you were managing yours, at least in that scenario, you wouldn't have to share credentials. But with CI, you do, right? That's number one. Number two, you have to do everything. I don't want to use the word in real time, but you have to do everything as they come. So if you do need to do the deployment, you actually have to do the initiation. You have to make sure that whoever needs access to get those things done have access to get it done. But enter GitOps, which is everything as code, right? You have tools that already kind of promote this culture with Terraform that essentially allows you to declare your infrastructure declaratively. Now, imagine you were not only able to declare your infrastructure declaratively, but you were also able to provision your applications declaratively. So you could just say, hey, I want you to run this application, and this application, and I want you to run 3 copies, 1 in development, 1 in environment, and maybe 3 replicas in production, right? And you also want these environments to be separated by, say, namespaces, or you want in one environment to have one thing or the other, right? Now, typically for this kind of effort, you would need a DevOps engineer who is, specifically focused on something like this, especially if you're in an enterprise environment. But with the GitOps concept, you don't really need to do all of that. The machine does everything for you while you declare everything as code. And then via pull request operations or via commit operations, you can capture your application and infrastructure set in state, in a immutable state. So if, for example, you wanted to upgrade your applications from version 2 to version 3, all you have to do is declaratively update your manifest, make a PR or make a commit. Your GitOps operator, in this case, what I'm going to show, Flux, will recognize the changes between the repository where all that code is and your cluster state and sync both of them to bring them up to date. And that is what the GitOps culture is. Now, here's the benefit. The Flux operator doesn't run in a third-party environment. It doesn't run in a CI server or in a continuous integration server. If you're using Kubernetes, it runs right smack in your cluster. So you don't need to share permissions. You don't need to give away, you don't have to worry about extra security steps. Whatever admin you need to do for your cluster as a whole, it will apply there. And you're not worried about rogue elements deploying unwanted applications, or even your engineers accidentally deploying applications and so on and so forth. In fact, I could say Flux is so, it can be very granular. Like you can actually restrict who can deploy what via namespaces or restrict cross deployments. All they have to do is give a repository for set of applications that each individual or each team needs to deploy, and all they have to do is make PR requests to that repository, and nobody is deploying anything directly. Someone can review the code changes and then deploy them declaratively, or someone, depending on how you operate, or you can auto merge, and once they have access to push that repository, they can make changes. I'm sure nobody will want to do that. Okay, so I think I've spoken enough. I usually like to show and not do. So I'm going to attempt to try and do a demo. And in today's talk, what I want to show is, one, how can we declaratively set up our cluster using Terraform? I believe everybody knows how to do this, but it would be great to see what the end-to-end would look like, from setting up a cluster to setting up your provisioning your applications, which you use, to all the way down to provisioning your software, your services. So notice I'm trying to separate services from applications. What I'm calling applications are your infrastructure applications, things like Redis or Server Manager or Nginx Ingress. But then your applications are your application services that actually serve your customers, either internal or external facing. Okay, so first thing we're going to do is try and prepare a cluster, and I'm going to jump into the screen now. I'm sure everyone can see it. If anyone can't see it, I've increased the font size. Can anyone let me know in the comments if the font is fine, if anyone needs me to increase it? Is it fine? She says yes. All right, cool. Okay, so the two repositories that I would like to share today. If you have you want to follow along, or you want to partake, the first repository is and they're both public. It's at my handle, github.com/Chuka Ofili, and it's GitOps-infra, which kind of like has everything, right? Both Terraform files, both the Flux configuration files, and then the second one is the GitOps apps, which is a simple guestbook application that allows users to say hello and keep a record of it. That's all that it is. But it is a monorepo. It has both an internal front-end service and it has a back-end service. There are other people who like to use separate repositories for different services. Well, it all depends on what you want, and you can use a singular repository. You can use separate repositories. I find for enterprise environments with thousands of services, it can be quite tedious to manage a lot of repositories at the same time. So I prefer to use monorepos where I cluster services that are co-located and not co-located, but are related together in one monorepo. That way, reducing the overhead and the footprint, and then I can federate permissions that way. So it is a monorepo. So I'll hop back into the GitHub infra, and then I will switch to my code editor. I'm praying to the demo gods that everything works out okay. So I have logged into my cloud console account, and as you can see, there's no new container environment. But before I switch to the command line, the first thing I would like to explain is this folder. Now, the Terraform folder is divided into two. One is the cluster and one is the provision, okay? Now, the cluster state is essentially how many nodes do I need, or I'm using GKE, by the way, Google Container Engine. So how many node pools do I want attached to my Google Container Engine cluster? How many, what type of nodes do I want? Preemptible nodes, blah, 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 blah. And these configurations, look at the Terraform file. I think everything that you need to understand is right in there. I won't take time to go through it, because I believe if you head over to the terraform.io website, the documentation is pretty straightforward. And then once you understand how to read that language, for those of you who don't know, that's the assumption. If you do know, then I think what I've defined there pretty much says everything all, right? So let's get our cluster up and running, and then I can keep explaining high-level concepts while that's going on. So first thing I'm going to do is I've set up the repository to include examples of what you need to add. So if you want to follow along with this example, there's usually always a Terraform auto TF-var example file with commented information on what you need to get to replace it. So I'm saying get your project ID, figure out what cluster name you want to create, base64, encode your credentials, which is essentially a service account file, which you can create from your Google Cloud Console IAM. And then once you've done that, create, you can see mine is here. I'm not going to click on it so I don't reveal my credentials, but then you'll be able to run the Terraform commands, right? And it's simply 3 commands now. So here it's going to be, I'll do a Terraform init, which tells it, well, go install all the plugins, providers, and everything that's needed. And then I'll do a Terraform plan to tell me what changes are going to be made. So what Terraform plan will do is check my current environment, check the cluster. Okay, I see the response. Right. So it will sync the cluster state between what you define in these files declaratively and what you have in the environment, and then you can apply. All right. Now, there's something that I'd like to mention here. So Terraform does have this service called Terraform Cloud, where you can actually link a repository to Terraform Cloud, and then via PR, remember the whole concept here is GitOps, and via PR, you can make a pull request to your Terraform Cloud connected repository, and then Terraform will sync the cluster state. So it will check the infrastructure you've defined declaratively and check what you have deployed, right? And then if there's any divergence, it will then sync and make sure that both environments are up to date, right? Peter's asking me a question, since I didn't specify out, did you just apply the last plan when you created, not this one? Well, because this is a demo, I didn't pay special attention to out details, right? So this is a fresh installation. There's no cluster. I didn't save the previous plan. I'm just running it fresh. Now, some people will use out so that they can reuse that plan, but I'm just doing it on the fly. So I don't need to save because I just wanted to create the cluster. Now, of course, that's a good point. You can actually use out to keep track of the plans as they diverge and as you version them, right? Yeah. Okay, so I was happy I was able to answer that. So this is just a demo, just to give it an idea. Let's not get what's the word? The details exactly will vary from case to case as you use it. So, this is just what I'm doing to get this up and going. So now this is deploying. It will take about 2-3 minutes. So while that's going on, I'm going to explain another high level concept. Now, I'll walk through the folder on the left, right? Now, remember I said I've got two folders. I've got, oh yeah, Jason, Terraform is awesome. I see your comment. Now, Terraform has got a, Terraform can actually install applications for you. However, most people prefer to use tools like Ansible, Chef, Puppet, because they feel like those are better orchestration tools. However, it is declarative, but it isn't, I don't know. I haven't used like Chef and Puppet extensively, so I don't know how versioning works with those. However, I was able to uniquely version using Terraform, version and provision applications and the infrastructure on top of the cluster in the same light. Now, the provision aspect, you can't, I found that I couldn't provision the software at the same time the cluster is creating. So I had to do it in 2 steps, which is 1, create the cluster, then provision the software. Now, most of the other software that I'll provision using Flux. And I've been mentioning Flux. If you haven't heard of Flux, go check it out. It's at Weaveworks. It's an open source project. Fantastic tool, right? I can't even begin to overemphasize, but I'm doing a hybrid. So what I'm doing is I've told Terraform, hey, look, install the cluster. And then when you finish installing the cluster, install Flux. That's the only thing, because I cannot use Flux to install Flux, right? That's like, what's the word? When you're chasing your own tail. Exactly, Jason, you're absolutely correct. I see your comment. So Jason says, Terraform to build infrastructure, use check Ansible etc to fine tune and configure it after it's built. Exactly. Now, what I'm doing with the difference between doing all of this using, Chef, Ansible is I'll declaratively do everything in 2 steps, right? So if you look at the provision folder, I just have 1 file again, as usual. And all I've said in this file is I said, hey, now that the cluster is done, okay, go and install Flux. What does Jason say? Chef, not check. Oh yeah, we got it. All right, so there's some things about Flux that I just wanted to highlight, right? Which, in case you are going to go through installation, it's good for me just mention this, right? First things first is the way Flux works is that it will connect to a repository where you've defined your application state. Now, we're talking applications. To me, applications that your environment needs to run, things like Redis, MongoDB, if you're that kind of person who wants to run MongoDB in a cluster, but I wouldn't advise that. But whatever it is you want to run, right? This is different from your services, right? Of course, the order in which an application should come up is you install your application, then you install your ad hoc service applications. So you install the cluster, my apologies, install your ad hoc applications, then install your service. Some of your ad hoc applications will be run by third-party services, like if you wanted to use Cloud SQL or RDS or so on and so forth. But most of the other ones you can run within the cluster. Now, Helm is a very powerful tool to do that. For those of you who haven't heard about Helm, I'm sure a lot of people have, but if you haven't heard about Helm, think of Helm like your package manager, right? For any framework that you use. So PHP has got Compose or Composer. Python has got pip. Node.js has got npm and yarn, right? So think of Helm to containers or Kubernetes as the package manager for it. So you wanted to install Redis, all you have to do was say, hey, take this chart, pass in the configuration values and say this is how you want it installed, and do a Helm install. Typically, you would normally do all those by hand, but luckily Terraform has a provisioner to do that. Now, the next question people will ask me, oh, so why don't I just declare all the applications that I want by hand? Well, here's the thing. What I do in this instance is because of precedence and order, I take the ones that are high level that I want installed on the cluster before I start installing anything, and I get Terraform to do those first. But then the rest, I get Flux to do those, because Terraform can actually install Helm applications and Flux can actually install Helm applications. So most of all the other applications that I install are done using Flux. Now, I get Terraform to install Flux using Helm, and then I tell Flux to install the rest of the applications using Helm. All right, not just Helm, but see, the powerful thing about Flux is, one, you can install using Customize. All right, you can install using Helm. So you can package your personal services as Helm charts and ship them off, and then declaratively, of course, for each environment, pass in different variables and then get Helm Flux to install those using Helm. Or you could just install using Customize. And what is Customize? Customize is a tool that allows you have different versions of your environment. So you would declare your environment once, and then you say, this is for services now, speaking about services. So you had this API that does XYZ, and you want the API to behave differently in staging and in production and in development, right? What you would do typically is you would have development set of files, you have staging set of files, and then every time you need to make changes, you would have to federate those changes across those files. Customize would allow you to declare once and customize. That's the whole point. So you'd have a base where you'd extend all the different overlays. Each overlay is for each environment. So you have dev, you have staging, and then you have production. And each of these overlays, Flux can install them. Now, you could do this by hand manually from the command line, but then why do anything manually when you do have these tools that can do all these things for you? So that's why I feel Flux is very powerful. Not only it can run customized files, it can run regular manifest files, and then it can run Helm installations all in one, all from a repository, and it can do it declaratively while you version it. I think that's the most powerful. All right, so our cluster seems to be ready. Take a look at the installation, the way I have ordered the installation in the Terraform file to install Flux. I think there are two key things that are important I want you to note. Number one is, once you've created your SSH key, you need to create a separate deployment user. I advise, because you don't have to do it, but I always advise to create a separate user who does deployments. So you create a separate GitHub user or Bitbucket user who does deployments. What are deployments? They're the people who actually auto deploy in certain cases if you're doing auto releases, which we'll talk about later. So in those instances, you need a separate user. I'd advise that. You can use your profile, but if that profile gets exploited, then people have, or compromised rather, people then have access to your environment. But if you give a deployment user who has limited access, then that deployment user is the only one who gets compromised. So take the credentials for your deployment for that user. If you're in an enterprise environment, what you should do is, from a team perspective, create a user who has access to a team, and that team has access to all your repositories, right? That's what I would do. But if you're a small company or this is just a hobbyist thing, then you just give that user access and invite them to all the repositories you want them to govern in that instance, right? Do auto deployments for. So that's the only piece of information that I wanted to say, that what you'll be telling Flux is you want Flux to act as that user anytime they're doing these deployments. So which means that user needs to have access to all the repositories that Flux will govern. That's just the high level point. A lot of people do forget that when they're doing the deployments. Okay, so now that our cluster is ready, I'm going to do a quick check of what's installed. Okay, I did have a previous cluster. Oh, by the way, this tool is called Infra. It's a GUI that allows me to visually look through my Kubernetes cluster for those who might be thinking. Oh yeah, it can't connect because I have not connected to my cluster. So I would check this out. All right, my cluster has been created. Test infra, as you can see. Click the connect button. Click on copy, and I will get that generated. Here we go. Okay, so now that that's done, I'll try to connect to it again. All right, this is my live cluster, and let's see if this is working. Sweet. Okay, so if you look to the left, this is a brand new cluster. There's nothing on it, no namespaces, nothing. Everything is just bare and it's empty, right? It's a fresh cluster. I wonder how many times we see this in our lives, but yeah, that's what that is. Okay, so now what I want to do is I want to provision Flux. But here's what's going to happen when I try to provision Flux. Because I say, hey, Flux, get installed, but as you get installed, also provision all these other pieces of software. And where do those pieces of software, where do I define them? In the Flux config folder, right? So the provision aspect, before I run a Terraform apply for provision, I just wanted to quickly take some time to explain what have I asked it to do. So if you notice, there are 3 folders in there. Now, this is not a standard or a convention, it's just how I prefer to do it. You could choose to structure your folder any which way you want. But I told Flux to always look in this repository in the Flux config folder to look for all manifest or all YAML files. So it will look for Helm release files, and it will look for regular Kubernetes files, and then it will look for customized files. Those are the 3 things it will look for. Oh, by the way, for your Flux to be enabled to install Helm releases, you need to install a second Flux chart. It's called Flux Helm release, but I've already instructed GitOps, the provisioner, Terraform provisioner, to install it for me, and that's it here. So I told you to install the Helm operator, and I told you to install Flux. So those are the 2 high-level things I need to get all of these things going. Now, remember, I've created my cluster now, and I just wanted to explain the things that I have pre-configured to get my cluster up and running, right? So the first thing is sealed secrets. For those of you who don't know what sealed secrets are, I'm sure a lot of people do, but I'll just say it again. So sealed secrets allow you to encode or encrypt one-way secrets in your repository. Now, it uses some sort of public-private key mechanism where the private key is kept in the cluster and then rotated every other, 2 days, 3 days, 1 week, depending on whatever you set to it. I don't know what the defaults are, but you would encrypt it using your command line, take the encrypted file, dump it inside your Flux repository, and then Flux would deploy it. And when it gets deployed on the cluster will decode it and create that secret for you. So that way you can safely keep encrypted secrets inside the repository, right? Because the only other way is to do it by hand every time you want to deploy. But remember, the whole concept is GitOps. Everything should go by PR. So you can actually add secrets via PR, or you have to use encrypted. And that's what sealed secrets is for, right? I've got Nginx Ingress. I believe this, for those of us who are in the container ecosystem, all of us, we know what Nginx Ingress is. It allows us to do, it's a global reverse proxy for your cluster, right? And that's what that is. So I just told it, hey, deploy Nginx Ingress, deploy this chart version. It's a Helm release, remember? Deploy it in this namespace. Remember, at this point, this namespace doesn't exist. I wanted to point that out. And I say, I want three replicas, I want a default backend, I want XYZ, I want all of these things, right? And then the default configuration for Helm actually installs a service that would vend a global IP that can use to access my cluster, right? Which is what I would hook up to my domain name in my, my masters, or like maybe with DigitalOcean or GoDaddy or wherever it is you host your domain, whatever. And then cert manager, very important, right? Today you need secrets, right? So how else to do the free stuff? The free stuff is the best stuff to do, right? So we've used cert manager to vend what's the word I'm looking for, to vend SSL certificates, and you can do that on the fly. You could also do wildcard certificates, but that's not what I'm trying to cover today. I'm only trying to cover just simple SSL certificates for the URLs or for the ingress endpoints that I want to generate. All right. And then finally, I've told you to do a simple MongoDB deployment. The reason why I need this MongoDB deployment is because the service which I need later on uses MongoDB, and I don't have enough time right now to go provision a Mongo Atlas or a third-party service to get MongoDB. So this is for a demo. It's quite straightforward. And then Redis, right? Now I'm going to leave Redis commented out so that you would see after Flux has completed installation how we add incremental applications and keep them in states. So now that we have, and I've explained, there's one more folder, the charts folder. So I've packaged our service, the third-party service is the guest book, which is from the GitHub's the GitOps-apps folder. The charts that does that installation, this is where it's kept. Okay, now I will take a look at that folder now, and I'll tell you how that folder is built and what I'm using to build it, and how I'm keeping things simple. But in the meantime, I'm just going to quickly run the provision endpoint to get things going. And again, I'm praying to the demo gods, let everything just work fine. Because I tested this 2 days ago, and I gave this speech not too long ago, and everything worked. But hey, you never know. Okay, so Terraform init, because of course I always like to run that, make sure all providers are up to date. And well, it says previously installed. I'll do a Terraform plan just to see what changes need to be made. Please let me know if the fonts are too small or if they're fine, and I can increase them. I know I mentioned this before, I'm just reiterating it. Okay, so they're fine for you. Okay, Jason, I see you, thanks. This shouldn't take long, I think, or I hope. This is just the plan phase, so, because of the data objects. All right, so now it's going to add 7 things, and I think I already explained what it's going to do here. So it's going to install Flux, install the Helm repository, create an SSH key, create a GPG key, link it to Flux, connect the repository, which I've already given it. Of course, as usual, remember I said that you could check the example file with all the things for the provision folder, all the things with the explanation on what each of those keys or variables are there for, so you can use this as a template to bootstrap your own environment. All right, so I'm just going to run and apply. And fingers crossed. Okay, so while I want to click yes before I start explaining. Okay, while that's going on, hopefully I'll remember. I want to jump into our GitOps application folder and explain our build component, right? Remember, it's make changes to your repository. Your CI agent picks it up, builds, and okay, there we go. I'll just say yes, and then I explain. All right, cool. We'll get that, leave that to go on. All right, so make changes in our repository, pick up the changes and build them. And then after we've built them, right, do nothing. Just build them and push them to our container registry and not do anything. So those are the three components, right? You need your repository, you need your container registry where the artifacts are kept, and then you need an orchestrator like Flux to see those changes or see changes from the repository where the GitHub repository where you define your YAML files and then make changes. So Flux does those two things, right? It keeps monitoring and scanning your GitHub repos or the public GitHub repo. Sorry, not GitHub. It keeps monitoring and scanning the Google Container Registry repositories and then the Docker Container Registry repositories for new versions of those containers. And anytime it sees a new version, depending on how you set up your Flux containers, whether you set to automate deployments, which means anytime it sees a new version of that Docker image, it will automatically deploy it. Flux will do that, deploy it, make APR, approve itself, and app itself, right? You can turn it off if you don't want that, right? But I think I'll leave it on for like dev environments and staging environments. So when people push, it will see those new tags and then deploy them, right? And you can be fine-grained with how you want to do it. However, the build component, right? So there are two things here. You can use a third-party build component, or you could cloud build. I'm using cloud build. You can use cloud build. You could use Circle CI. I also use Circle CI on some other projects. Or you can use a simple server. All that server needs to do is be able to run Scaffold build, right? Now, what is Scaffold? So Scaffold allows me and my engineers to use the same environment locally, or use compute power in the cloud locally, right? So I wanted to say build, once I was doing some sort of Python application that had a lot of maybe it was machine learning. I once worked on a project like that where it needed the build process was it took forever before it even got the container running, and then before it would analyze the data and the stats, it used to take time. And my computer, even though it was powerful, I needed more compute space. So what I did was I created a namespace in my Kubernetes cluster, and then I connected Scaffold to it. So I was building locally and working locally, but I was using compute power over there, right? The way Scaffold works is magnificent. I did a video on how to use Scaffold. Please check out my YouTube channel. There's more information on that to explain that. I know it's a shameless plug, but hey, that's that. All right, so I'm using Scaffold. Now, all I've checked, the two important things you need to see in this configuration. The first is the Scaffold, the YAML file, and the cloud build file. All right, so the Scaffold, the YAML file, it's a simple configuration that just says, here are the applications here. This is the context, which is where the Docker files are. This is essentially part of the Docker files, what you should name the images. And then the final bit is the cloud build, which is when it does get pushed to GitHub. Oh yeah, remember you do have to connect cloud builds to this repository, right? Which I believe everybody knows how to do. All you have to do is install the GitHub app, the cloud build app, do the connection, give it the permissions, and it'll be synced so that once you do a push to GitHub, cloud builds will see those notification changes and then run the steps that you've kept in this cloud build file. As you can see, it's quite simple. I just told it to clone this repository. And then after you've done that, build the repository. And then once you're done building, tag it properly. And then, oh yeah, Jason, thanks for that. I see. So Jason just posted a link to the YouTube video. Nobody minds. Anyway, so you build that, and then Scaffold will build it and tag it appropriately and then push it. But why I like using Scaffold is because this build that the CI did is not different from the builds that I use to work locally. And whether I'm using my local compute resources or whether I'm using the cloud compute resources to build, right, while I'm developing, if I'm using cloud compute resources, it will build it and deploy it in the cloud and then symlink and hotlink those folders in the cloud in those containers to my local system. So if I make changes, if I orchestrate it properly using things like NodeMon for JavaScript or PHP, you don't need to, it hot reloads. Immediately I make changes, Scaffold would quickly swap out those files in those containers and you could see them in real time deployed on the web. So that way you're not using any local compute resources. So, but if it's working locally, be rest assured that if I make a PR to that repository to get it built, those Docker artifacts will build, and when they get deployed, they would always work because they already work locally using Kubernetes in the environment, right? It's not like I'm developing locally without Kubernetes and without all of that, we always get into this, oh, it's working locally, but it's not working online after deployment. This just eradicates all of that. All right, so that's the only high-level point I wanted to highlight. Traverse the repository, you would see the folder structure and the layout and how I kept it, where the Docker files are, how I built it, and so on and so forth. All right, so let's get back. All right, so now the Helm, the Terraform has finished everything. Okay, Donglu says you can also inject environment variables with Scaffold on flag. That is correct. But remember, Scaffold is just building the artifacts, right? Remember, we're separating deployments from the build process or from the integration process. We want to give deployments somebody else's responsibility, a machine, most likely, and everything is done by a pull request. But you are absolutely correct, right? So now I'm going to check out our cluster state and see if anything has changed. There we go. So as you can see, things are still getting installed. Flux is installed. You can see all the namespaces have been created, staging, production. These are all things that I declared, I did declaratively here, right? If you check the workloads. So this is just how I decided. So I have the dev environment, I have the production environment, I have staging environment, and I've said, deploy all these applications here, right? Oh, I didn't even turn off this one. But anyway, so these are all the namespaces that I deployed. This is the my cluster issue for Cert Manager. Everything is just going to do it. Now, of course, some of these things need precedence, but why I like Flux, why I like Helm, why I like the way the whole systems work is that Flux will keep trying even though it's failing. So if it wanted to install, let's say, Cert Manager and the namespace didn't exist, it will fail at that point. But remember, because Flux is still doing everything, it will eventually create the namespace and then retry creating the Cert Manager. So at some point, it will succeed. Oh, wow. It says we'll be moving to the next session in about 5 minutes. Okay, so, okay. I think the high level concept, I think I've passed along because we're actually at the tail end of the demo. Or yeah. So system, you can see my MongoDB stateful set is running. In deployment, you can see both my guestbook for front end and back end is running. But I haven't done one bit, which is very crucial, which is I need to get the IP and then link it to I get to get IP from the Nginx ingress. Hopefully that's been. Is this suitable for personal projects? Absolutely, Jackie. This is everything I just showed you is personal. All right. So this is my IP. This is my Nginx global IP. So with this IP, if I go in the browser, I should see like a default for not found that lets me know that everything's working okay. All right, you see, everything's working okay. That's the default. So if I went to DigitalOcean, all right, I hope we have enough time for us to show the guestbook application, but I'm sure everybody gets the high level concepts. Where are we going? I should have opened this down, my apologies. So I did this before, so all I have to do is just change the IP address that was previously there. Okay, where are we going? Networking, what am I looking for? Chuka.dev, there we go. All right, so this is the URL I want to change. Oops. Okay, all right, so I'll just give that a couple seconds. It should update almost immediately, right? But anyway, what are we checking for? Now, remember in my guestbook application, I wanted, this is the guestbook application for my dev environment. I'm using Helm charts as I mentioned, right? So, and I've told it, look inside this current repository. This is the path to the guestbook chart. It's in the master branch. this is the repository for the front end, this is the repository for the back end, and this is the tag that you should deploy one replica, and so on and so forth, which it has done all of that, right? We could check again. As you can see, yeah, you can see the tag that's deployed. That's the tag that was deployed. Now, if I did a, if I got my repository to build again and push and deploy a new tag, because of these tags that I've specified, Flux would see this and automatically redeploy them because I've said automation is true. If I turn it to false, it won't deploy that. But more importantly, if you check my values file, I actually did specify URLs that need to be accessed, right? And I enabled TLS, and I told it, go vend, let's encrypt certificates, install them, and so on and so forth. So I know it might take some time to actually do, because of course I just did the linking, so the certification might fail soon. So when you're ready, we can wrap up and move to the next talk. All right, cool. I think I'm actually done. I just wanted to test to see if this will work. Well, okay, so certificates haven't been vended yet, but of course the URL is up and running. If I did a curl, I'm sure this would work okay. Oops. How do you, yeah, anyway, I'm sure everybody knows what that's about.